How to choose an API security tool. At a certain point, API security vendors all start to sound the same. But the wrong choice means coverage gaps, wasted budget, or security testing that slows down development instead of enabling it. This video will teach you how to cut through the noise and match the right API security solution to your specific needs. Step 1. Assess your API landscape. Start by understanding what you're protecting. What protocols are you using? REST, GraphQL, gRPC, SOAP? Where are they deployed? Cloud, on-premises, hybrid? What's your architectural pattern? Monolith, microservices, serverless? Key questions to ask include, how many APIs do you have documented? How many undocumented or shadow APIs might exist? Are your APIs internal only, partner-facing, or public? Understanding your environment determines which tools can actually handle it. Step 2. Match tools to your development stage. Different tools address different stages of the API lifecycle. Shift left tools integrate into development and CI/CD for testing before production. Production runtime tools monitor live traffic for threats, behavioral anomalies, and compliance validation. Most organizations need coverage at multiple stages. Testing catches problems before deployment. Monitoring detects attacks that are already happening. Ask yourself, where are your biggest security gaps? During development or in production? Step 3. Consider your team structure. The effectiveness of any security tool depends on who's using it. For developer-led teams, choose tools that fit their workflows. Look for GitHub and GitLab integration, clear actionable findings, and fast scan times that don't slow down CI/CD pipelines. For security-led teams, prioritize centralized dashboards, detailed compliance reporting, and integration with security orchestration tools. The best security tool is the one your team will actually use consistently. Step 4. Evaluate integration capabilities. Your API security tools should work together, not create data silos. Does it integrate with your source control, issue tracker, CI/CD pipeline, and communication tools? Look for tools that correlate findings across the security lifecycle. When static and dynamic testing tools share data, you get context on which code vulnerabilities are actually exploitable. Step 5. Account for compliance requirements. PCI DSS requires continuous API security testing and maintained API inventories. The EU Cyber Resilience Act mandates security testing throughout the development lifecycle. ISO 27001 now includes specific controls for API security. Ask vendors, does the tool meet your compliance standards? Can it generate audit reports? Does it provide evidence of continuous testing and complete API inventory? Step 6. Balance cost against coverage. Pricing models vary significantly. Some charge per developer, others per application, per scan, or per API. Calculate total cost of ownership, including licensing, implementation, and maintenance. Consider how pricing scales as your API count grows. What's included in the base tier versus enterprise features? The cheapest option often isn't the most cost-effective if it leaves gaps in coverage. Step 7. Prioritize accuracy over volume. A tool that finds 100 vulnerabilities with 90% false positives is less valuable than one that finds 10 real exploitable issues. High false positive rates lead to alert fatigue, where real vulnerabilities get ignored. Questions to ask vendors include, what's your false positive rate? Can you demonstrate findings on our actual APIs? How do you validate exploitability? What remediation guidance do you provide? Ready to compare API security solutions? Check out the full article linked in the description.